Alright, in these videos, we're going to look at radicals and rational exponents, which, as we'll find out, are actually two ways of representing the same thing. So here I've got some radicals we're going to simplify. And so a radical refers to anything that has a root symbol. So, there could be a square root, or a cube root, or a fourth root. Anytime you have a root symbol, it's called a radical. So the thing to remember when you are simplifying radicals is think of it like the numbers and variables inside a radical. They want to escape outside of the radical, but in order to do that, they have to be a perfect fit. So, like for a fourth root here, you have to have a perfect fourth power to go outside the radical. So here I've got the fourth root of 81 over 625, okay? So in order to take something from inside to outside, it has to be a perfect fourth. So here's what I mean by perfect fourth. So like 1 to the fourth is 1, okay? 2 to the fourth is 16. 3 to the fourth, is 81, okay? So 81 is a perfect fourth. So the fourth root of 81 is 3. So basically, you can simplify that 81 to simply be a 3. And similarly, for 625, we're looking for a number that, if I take that number to the fourth power, it'll be 625. And as it turns out, that 5 to the fourth power is actually 625. So the fourth root of 81 over 625 reduces down to just be 3/5. Okay. Now, a calculator can help you out with these. Like if you're not sure, hey, is the 625 a perfect fourth root? Most calculators have a fourth or a cube root function. So if you're not sure to do that on your calculator, just ask me and I can help you with that. All right, so let's look at the next example. I've got the cube root of negative 64. So I'm looking for a number that, if I take it to the third power, will equal negative 64. And I know the number is going to be a negative because since I have negative 64, a negative times a negative times a negative is going to end up being negative. And so the answer ends up actually being negative 4. Reason being, if you take negative 4 to the third power, you get negative 64. So the cube root is actually the inverse operation of a cube, so it undoes it. So the cube root of negative 64 is negative 4. All right, next we got kind of a special case. I've got the square root of negative 36. Now when you first see this problem, a lot of students for the first time will think, oh, it's got to be negative 6. But that doesn't work because negative 6 squared is a positive 36 because a negative times a negative is positive. And same thing, it can't be positive 6 because positive 6 squared is also 36. So what's the answer? Well, for this one, there actually is no real solution. Okay, so you might remember back to Algebra 2 something about imaginary numbers, and we're going to talk about those later, but for now, there is no real number that you can take the square root of negative 36 and get it. So, and that'll be true anytime you have an even root, like a square root or a fourth root or a sixth root or eighth root, etc. You can't have a negative number inside of it. You'll get no real solution. Odd roots, like on this example here, are fine. Because a negative times a negative times a negative is negative. But even roots, you can't have a negative inside. All right, so let's look down here. So I've got 72 w to the 7th, and it's a square root. When there's no symbol there, it's just implied to be a square root. So now 72 is not a perfect square. If I look at the perfect squares, go down the line, I got 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, and 6 squared is 36, etc. Now, if you keep going, you're not going to get 72 to be a perfect square. Okay, but that doesn't mean that we can't simplify this, because even though 72 is not a perfect square, there are perfect squares that go into us. And In fact, 4 goes into it, 9 goes into it, but bigger than that, 36 goes into it. So 36 is the biggest perfect square that goes into 72. So what you can actually do is you can rewrite square root of 72 to be square root of 36 times 2. Okay? So square root of 36, not 32. 36 times 2. And then you can take the square root of 36 part outside. Now when you take it outside, it becomes a 6 because the square root of 36 is 6. So you have square root of 36 outside of it, became a 6. You still have the 2. The 2 is basically trapped inside the square root because it's not a perfect square and nothing goes into it that's a perfect square, so you can't take it out. Alright, so that takes care of the number part, the 72 part. What about the variable? I got w to the 7th. Well, w to the 7th is not a perfect square, but there are, once again, just like the numbers, there are perfect squares that go into it, because if you were to take the square root of w squared, that's just w. So anytime you have a w squared, you can take it outside of the square root. And there's actually several squares that go into w to the 7th. You can break down w to the 7th to be w squared, w squared, w squared, and then w to the 1st. Okay? So if you think of w to the 7th as being squared, squared, squared first, notice how this adds up to 7, 2 plus 2 plus 2 plus 1. Each of these w to the squareds can be taken outside of the square root. And there's 3 of them, so when you take them all out, there's a w to the 3rd on the outside, but then there's still 1 w left on the inside. So these 3, each of them came out and became w to the 3rd. This w here was stuck inside. So this is after you've taken all the perfect squares you can, that's as far as you can go. Alright, so let's look over here. I got cube root of 32 x to the 6th y to the 5th. So cube root, I'm looking for perfect cubes to take out of here. So let's look at the 32 first. What are some perfect cubes? Well, 2 cubed is 8. 3 cubed is 27. 4 cubed would be 64, but obviously I don't have to go that far because 64 can't go into 32, much like 27 can't go into 32. In fact, 2 cubed is the smallest, or is the biggest perfect cube that goes into 32, so I can rewrite 32 to be 8 times 4, okay? And then I will be able to take this 8 out front, okay? Now what about the x to the 6th, y to the 5th? Now, x to the 6th, you're looking for perfect cubes that go into x to the 6th. So obviously, you can have 2 x to the 3rds go into x to the 6th. You can break down x to the 6th into x cubed, and then each of those will be able to come out. What about y to the 5th? Well, 3 doesn't go into y to the 5th evenly, like a perfect number of times, but you can still break down y to the 5th into y to the 3rd, y to the 2nd, and you'll be able to take out one group of 3. So we have to take out groups of 3 because it's a cube root. Alright, so let's look here. I got 8, which is the cube root of 8 is 2, so I can take that out front, make it a 2. I've got 2 groups of x's into groups of 3, so I can take out x squared, it becomes on the outside. I got 1 y to the 3rd I can take out, so it's just going to become y to the 1st on the outside. Then what is still trapped on the inside? Okay, well, this 4 is still there. There are no more x's on the inside because they came out perfectly. There is, however, still a y to the 2nd trapped on the inside. And so this right here is as far as you can go. 2x squared y times the cube root of 4y to the 2nd. Okay, so when you're simplifying radicals, just remember whatever the root is, you're trying to take out perfect powers out of the root. So like cube root, you're looking for perfect cubes. Fourth root, you're looking for perfect fourth powers. Square root, you're looking for perfect squares.